So actually evaluating logarithms doesn't take very long. It only takes a couple seconds for each one, just as long as you know what's going on. So in the second part, it asks us to find the exact value, but in the first part, it wants us to write the following in exponential form, like the page before, but then it wants us to solve it if possible. So for number 5, log base 3 of 9 equals 2. So we're going to rewrite it in exponential form. That's gone. We now have 9 equals 3 to the second power. So that is true. So we must have rewritten it correctly. 9 does equal 9. Now for number 6, log base x of 8. That x comes over and becomes the base for the exponent of 3. And we're left with just 8 on the left. So for this one, we can actually solve what to the third power equals 8. So if you still have that power sheet from Unit 3, you can go ahead and use that, but also just thinking what times what times what, the same number 3 times, is 8. 2. 2 to the third power is 8. So in that case, we could actually solve for it. Same with number 7. Bring that base over. This becomes 4 to the power of x equals just 64. So 4 to what power is 64? So in the last problem, we solved for the base. In this problem, we're solving for the exponent. 4 to what power? 4 to the third power would equal 64. So x is 30. So now if it asks us to find the exact value, we have to find what it equals. So it might be easier. I think sometimes people like to either put a question mark there or put x there. But we're trying to figure out 5 to what power equals 125. So 5 to what power is 125? 5 to the third. So this whole expression, log base 5 of 125, equals 3. You're solving for the exponents. That's what logarithms are used for. So for number 8, remember, if you don't see a base, it is base 10. So that's going to come over. And we're going to say 100 equals 10 to the base, or 10 to the power of what? Well, 2 zeros, so 10 squared. So log base 10 of 100, that expression equals 2. Log base 5 up to the of the 1/5 equals what? So 1/5 equals 5 to what power? Okay, a whole number, fraction. So I know it's going to have to be a negative value. I just have to figure out what negative value. So if we think about this, 5 to what power is 5? To the first, right? But to put it or get it in the denominator, for it to be in the denominator, that means that exponent had to have been negative. So 5 to the negative first would move that 5 to the bottom, you put the 1 in the top of your fraction. So negative 1. So if we look at number 11, log base 4 of 4 to the 6th. So I personally know that if I have a log base 4 and an exponent with base 4, that they will cancel and I'll be left with just the 6. But if we rewrite this, 4 to what power equals 4 to the 6th? Well, if the bases are the same, then that question mark has to be 6. For them to be equal, they need equal exponents. So, when you guys have a log base 4 and an exponent with base 4, they cancel, and your answer is just what you're left with after they cancel out. So for 12, same idea. Log base 7, exponent with base 7 gives you just 4x. So we don't have a value, but we can at least simplify it and see what this expression simplifies down to or equals. In number 13, this is where we talked about the natural log and the base e. We have a natural logarithm, an exponent with base e, so that natural log and that e are going to cancel each other out, and you'll just be left with that 601. Natural log, exponent base e, inverses of each other cancel each other out. They're the exponential and log versions of each other. So, same with number 4. Now, we talked about log base b within an exponent base b. It works the same way if you have an exponent with said base, and then the exponent has that log with the same base in it. So, like for number 14, this is log base 10 of 4. This is your exponent. I know sometimes it's hard to see the difference, but that log base 10 of 4 is your exponent. So if you have an exponent with log base or base 10 and the exponent itself is a log base 10, they are going to cancel out and you'll be left with just 4. I'm going to go back to 15, but for 16, same thing. Just don't have our equal sign there. Equals what? Log base 7 with exponent base 7 cancels out. And that whole entire expression equals -4. Now for 15, we can rewrite this as 5 to what power equals 25x. So 5 to what power equals 25x. Well, if they're not the same bases, can we rewrite that left side so that it does have the same base? So if we rewrote 25 with the base of 5, 25 is the same thing as 5 squared, correct? 25 is 5 squared, but that x is still there. So now, in order for these to be equivalent or equal, we have our 5 and our 5, so this has to be equal to this. So 2 power of 2 to the power of x means that that whole expression equals 2x. So again, rewriting or manipulating things so that we can operate or work with them. So when you guys are trying to find the exact value, you rewrite it in exponential form and then go from there.